Hello everyone, so in today's video we're going to be going over what pointers are and how they work. Pointers are amazing little things, and people will try to tell you that they're hard, and people will try to tell you that they're not hard. Um, I'm not going to tell you either one of those things, because both people are wrong and stupid for trying to say it either way. Pointers are not simple, that's true, but they're not complicated either. So trying to say that it's on either polar side of that is kind of ridiculous because it's not true. So, yeah. If you hear someone say pointers are really hard or someone say pointers are really simple, don't listen to them because if they're saying it's not simple, they're probably trying to make it so that you can listen to them and try to like gain information which everyone else has, but seems like only they have. And if you listen to people who say it's really hard, they're probably going to make it sound really, really difficult to you. Because that's how they perceive it. Here is what a pointer actually is. A pointer is a variable that holds the address of other variables, and that's really it. The AND operator and the asterisk operator are the only two things that you'll really need with pointers, and they both have functions or like abilities that make them like not needed but preferable to someone. And so yeah, we'll kind of just get into exactly what they do right now. So first, let's make two variables. We'll make int p and c, or my bad, int asterisk p comma c, because that will make that a pointer. Now, what we want to do here is we'll say c is equal to 10, comma, so that way, you know, c is initialized to something. And now we can actually go through and start testing things. Let's say p is equal to ampersand c. This means that c, or not c, p is now the pointer to c. It's pointing to the memory location of c because the ampersand gives you or returns the value of c, and that's it, or not the value, the location of c in memory, and that's it. So if you've never seen memory before, this could be kind of something cool for you. But what a memory strand actually looks like is usually something 0x BFF and might not even be BFF, but anyways, that's what they look like. They're hexadecimal, so if you've never seen hexadecimal or you don't like hexadecimal, you'll have to get used to it if you see memory addresses a lot. In this video I'm not going to show you how to print those out though, because it's kind of pointless and you can probably figure it out yourself. It's just %p to like give you a pointer, and like %x to give you hexadecimals or to format it in printf. So yeah. Anyways, p is now equal to the memory address of c. Now, if we were to do something like printf %d percent or quotation comma c, or my bad, asterisk p semicolon, what this will do is give us the value of c. It'll tell us 10. And the reason is that the asterisk is the dereferencing operator, so it goes to that address and then finds what that is looking at. It's really not that difficult, but it sounds difficult for sure. Here is our logic so far. We have integers pointer p and integer c. C is equal to 10 and p points to c. Now the asterisk points to the value that c has, which is 10, and p holds the address of that. So the asterisk just visits that memory address and returns what's there. So if we run this, you'll see that we get 10, which is what we should get. It's very simple. Awesome. Now, what if we get rid of that asterisk? Now we get 22,93332. Interesting. Well, that's because now we're printing out as a decimal the address of this. And I know I said that I wasn't going to show you, but if we do that, we get our memory address. Yay! So this is the actual address in memory, 0x22FE54. That's the value, or not the value, the memory address of our variable c. Something to note is that a pointer cannot point to not a constant. There's a better word for it. What am I looking for? Expressions. Yeah, there we go. And that's important to note, because that means that you can't, that statement alone means that you can't have it point to like 5 plus 2 or C plus D. You can't have it point to just 5. You also cannot have it point to register variables, which we will go over later what a register variable is. And let me tell you, register variables, weird things. They're kind of really not important anymore, but yet they're still part of the standard language. So yeah, pretty weird things. Alright, so what else is there about pointers? Well, let's actually do a little bit of like pointer magic kind of stuff. So let's make 3 integers, x, y, and array 10, array of size 10, z. So integer x equal to 10, comma y equal to 5, and comma z size 10. Okay. So now that we have our variables, let's make integer pointer IP for integer pointer. And down here, let's say IP equals ampersand x. So it points to x at this point. IP points to x. By the way, if you don't know what this like slash asterisk blah 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 asterisk slash is, it's a comment. It's ignored by the compiler so that you can kind of leave yourself notes in your code. So I think I'll probably start using those a little bit to make it easier for you guys to understand what we're doing. Next, we're going to do y is equal to asterisk IP, which means that now y points to x, or is equal to x. I guess would probably be a better way to say it. Oops. Equals is, yeah, y is equal to x. Alright, and now we'll say IP is now pointing to 0, and IP is equal to ampersand z 0. Well, actually no, let's get rid of this line because it can't happen. I was going to kind of show you guys an error, but that just can't happen. Instead, let's replace that line with something that initializes z. So z is equal to 1, 5, 8, 6, 10, 9, 7, 2, 3, 0. Yeah, and so that's 10. And we'll end that line. Okay, so now here, IP points to z index 0. Alright, so to prove this, at each point down here, let's actually just print out what IP is equal to. So printf percent d new line, and we'll say IP, or my bad, asterisk IP, semicolon, then down here printf percent d backslash n. We can just say y, and then down here we'll say printf percent d backslash n, and then yeah, asterisk IP. Now we'll compile and run it. Yay! Oh, error. Expected before. Expected expression. Alright. Alright, there we go. Now we'll compile. What is this? Expected blah 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 before. Oh, my bad. Semicolon there. Compile and run. And we get 10, 10, and 1. And then, yeah. So, right here in our code, we print out whatever I is pointing to, the value of whatever I is pointing to, which is x, which is 10. Then we set y equal to what IP is pointing to, which is x, which is 10. So it prints out 10. Then we set IP equal to the first element of z, which is 1, and it prints out 1. And that's basically some things that you can do with pointers. There's really nothing else that's magical about them, so again, they're not super complicated and they're not really easy because it's kind of confusing. I mean, you're dealing with actual memory. This is where you're pointing to memory addresses and retrieving the information from there. They work in a more complicated way than what some people will tell you, but they're not so complicated that you can't understand them. And pointers are going to be used in so many programs that you make. It's ridiculous. And before we leave, actually I want to show you one more little thing about pointers. If you make a char pointer x, and then you say x is equal to, and a string, this is a string, something awesome happens. If we printf this and format it as a string,